transfer takes place. First stage, second stage, third stage, and the instrument unit going to internal power. T-minus 37 seconds, and our count continues to go with T-minus 25 seconds and counting, and all 13 is go. T-minus 20 seconds, T-minus 20 seconds and counting. 17, guide mark the power transfer. 6,
When I was a young kid, I learned a little bit about what the Germans were doing in V-2s, because this is during World War II, and I got really interested in rocketry. Eventually then, at my senior year in high school, I got hold of a pamphlet by Robert Goddard. He was a scientist in Worcester, Massachusetts, and had written a pamphlet, this is 1913, on using liquid rocket engines to obtain high altitudes. And I didn't understand a lot of what he was saying, but it got me very much interested. And so my senior year in high school, a friend of mine and we built a little solid rocket, just to keep the enthusiasm going. And I went into University of Wisconsin, mechanical engineering. I can't tell you today why I did that, but I kind of thought that would finally lead me, if I could get a degree in mechanical engineering, I could get into whatever I wanted to do. I, and probably just about everybody else, didn't really think about space flight except in a more or less in a fantasy type thing. I've read a lot about all the comics about space people and things like that, and of course I was interested in rockets and going up there, but it was all imagination at this particular time until NASA put out the requirement for doing the Mercury program. The first time they asked for astronauts, I was I had a graduate of a test pilot school, and so I was asked if I wanted to join the group, and I said, well, certainly, yes. This is what I've always wanted to do, and I went to take my physical with the original 32 that were thing, and I was the only guy to flunk. And I was disappointed. And then about 2 years later, I knew NASA needed some more astronauts, and so they finally came out and asked for more volunteers, and the Navy called me again and said, are you interested in getting back in the program or getting into the program? And they didn't know that I had flunked the physical the first time, and I said, certainly. And then I applied again, and then I made it through the Gemini program. When I came back from Apollo 8, I was assigned to Neil Armstrong's backup commander of Apollo 11. And during that time, Buzz Aldrin was the co-pilot to Neil for the Apollo 11 flight. And there was a lot of animosity because Buzz thought that he should be the first one to walk down the ladder and step on the moon. One time, NASA management talked to Neil and said, look, if you want to, we'll replace Buzz with Lovell. And Neil said, no, I'll stick with Buzz only because I know that Jim wants to be a commander of one of these flights, and if he goes as a secondary guy, then he probably, because he'd be on the moon too, that he'd be asked to do other things and never get another flight. And so it was Neil that said, I'll stick with Buzz. Apollo 13 was the most unusual flight. Being on a flight that had an accident 200,000 miles from, and getting back safely, working closely with mission control, but doing all the execution of the stuff that we had to do, it really is more of an indication of the ability of what someone can do than just being the second guy on the moon. Well, Apollo 13 was going to be the third lunar mission. We were going to go to a place called Fra Mauro. This is going to be a sort of a mountainous type, or more of a hilly type of facility than the previous two flights, and because they thought that the material there was different than the material that had been brought back on 11 and 12.
13, we've got one more item for you when you get a chance. We'd like you to stir up your cryo tanks. In addition, I have shaft and trunnion for a look at the Comet Bennett if you need it.
Okay, stand by.
First of all, when they were building the liquid oxygen tanks, the company building the liquid oxygen tanks dropped a tank on the factory floor. The tank was originally going into Apollo 10, I think, but because it was delayed, that was rescheduled for Apollo 13. They picked it up and they rechecked it to make sure that it could do its job, deliver oxygen to the spacecraft for breathing and for making electrical power. Everything worked fine. But the tank had a second objective, or second function, I should say. There was a tubing inside that tank so arranged that after a test, they could remove the liquid oxygen by just blowing gaseous oxygen in the fill line, and it would be forced out the vent line. That too was damaged at the drop of the tank. They did not check whether that would function or not. Now, let me go back to 1965. At the launch site, there was 65-volt power available for operations. Even though the spacecraft flew at a 28-volt power system, they thought that if something just happened to the spacecraft on the launch site, why don't we make it capable to use that power? So the manufacturer of the spacecraft told the manufacturer of the liquid oxygen tanks, remove the thermostats and replace them with ones that are capable of handling 65-volt power. The thermostats were never replaced. And the spacecraft manufacturer never double-checked to see that that directive was complied with. Okay, now back on the launch site 2 weeks before the launch, they try to remove the liquid oxygen. Impossible. So they said, well, wait a second. We have power out at the launch site. That's 65-volt power. They're protected. Why don't we just apply that power? And inside the liquid oxygen tank, there was a little heater. And the heater was used during the flight to convert some of the liquid into gaseous oxygen to function into the spacecraft. Let's turn that heater on and just boil the oxygen out at that time because everything else was fine. That's what they did. Turned the heater on. And sure enough, as they were protected, the liquid oxygen started going to gases, but the temperature in the tank rose. When it got up to 80 degrees Fahrenheit, the little thermostats, capable of only 28, started to open up to protect the thing, but the 65-volt power welded them shut. And from then on, there was no protection. We know now that the temperature inside that tank got up to 300 or 400 degrees Fahrenheit. Took all the liquid oxygen out, no bomb, no fire, but melted all the protective wiring on there and exposed all the wiring to a potential spark of some sort. But it was not detected. Nothing happened. Oxygen was removed. The day before the launch, the tank was filled up with liquid oxygen. From that time, the tank was a bomb waiting to go off. 200,000 miles from space on April 13th, Schweikert threw a switch to turn on the heater a little bit to get oxygen, and the tank blew.
Okay, yes, we've had a problem here.
What's the matter with the data?
Heater current looks normal.
Okay. We got more than a problem.
Okay, listen, you guys. We've lost fuel cell 1
This is Houston. Say again,
and 2
please.
pressure.
We lost O2 tank 2 pressure.
You want to look at it?
And temperature.
Houston, we've had a problem.
Okay.
Stand by, they got a problem.
That'll be both wonderful.
I heard just a big sharp bang, and the spacecraft rocked back and forth, And then I looked up at Fred Hayes to see if he knew what caused the problem. And then as I got into the command module, I looked at Jack Swiker, and his eyes were as white as saucers. He didn't know what the problem was. But the first indications that something was wrong was the fact that I noticed that one of our fuel cells was inoperative. And then as I started to glance around at various things, I saw that in our indicators of the liquid oxygen, one tank was empty and one tank had the fuel oxygen going down. And so I knew that something was desperately wrong. I can't tell you why today, why I looked out the window, but when I looked out the side window, I saw escaping at a high rate of speed, sort of a fan system that of gaseous substance.
And it looks to me, looking out the hatch, that we are venting something. We are venting something out into space.
Roger, we copy your venting.
It's a gas of some sort.
And it didn't take much intelligence on my part to understand that the quantity gauges that I'm looking at and the gas that I was seeing, that we were losing all of our liquid oxygen. And very quickly, we'd be out of liquid oxygen, and essentially the whole command module would die. This was a flight that was snake bit right from the very beginning. And so when the explosion occurred, you know, that was the epitome of the problems.
Here in Mission Control, we're now looking towards an alternate mission, swinging around the moon and using the lunar module power systems because of the situation that has developed here this evening. This is Apollo Control, Houston.
When that explosion occurred, my dream evaporated. I knew that there'd be no landing of 13 on the moon, regardless of what the situation. Even before I knew what was happening, I knew that there was, and it was only after I came back and landed safely that I was disappointed that the situation occurred that I never could land on the moon.
Can we review our status here, Si, and see what we've got from a standpoint of status? What do you think we got in the spacecraft that's good?
The explosion occurred at just the only place that it could have happened that would result in a successful recovery. If it happened any time after we got in lunar orbit or when we were on the surface, we'd never have the fuel to get either back up to rendezvous with the command module or even to get uncaptured by the moon.
Okay, does it look like it's still going down?
It's slowly going to zero, and we're starting to think about LEM lifeboat.
Yeah, that's what we're thinking about too.
Well, we all came to the conclusion that the only way we were going to get home was to use the lunar module as a lifeboat and what it has, and does it have enough oxygen and things like that. Well, the lunar module was not a device you want to spend a lot of time in. It was designed for 2 people for 2 days. And of course, we had Swiker that came in too, so there's 3 people that were there, as we've determined now, for at least 4 days to get home. And so it was kind of cramped. And of course, the first thing we had to do was power down everything, so to save electrical power. But the main thing that we had to worry about, we found out, was the carbon dioxide in the lunar module. It took a bit of innovation and in thinking to make that difference, and we did it. And so, you know, I'm really happy that the crew got the information and we could actually make it so that we wouldn't pass out by starting to breathe carbon dioxide. As we got towards the Earth and we're getting ready to take care of everything, we managed to get electrical power back into the command module's battery, so have enough power there to have the command module alone for the descent. As it floated away, we could take pictures of the whole side of the service module being blown out. And that's when we worried about, well, that was kind of close to the heat shield. Did it damage the heat shield at all? But there was nothing we could do about it anyway. If the heat shield was damaged, it was damaged, and so that was it. Well, then after we got rid of the service module, we eventually got rid of the lunar module, and we were by ourselves in this command module again. And hopefully that with the power now, we have the computer running again, and it knew where we were, and it knew where we were supposed to land. At least that's what we hoped it did with all this rearrangements. And so we got into the back end and we started our descent. But it wasn't until we were safely on the water and I could see droplets in the window and knew that we had come back to the Earth, that unless the task force was someplace else, I think we were in pretty good shape. Well, I think that our odds at the time of the explosion occurred. Well, we knew we lost the command module, that whole system, they're pretty low. But the thing is, when you're in a situation like this, you don't think of the odds. You think of only how to improve the odds. It was a beautiful case of good leadership, good teamwork, and the good use of initiative. By the ground control people who did a great job working closely with the crew who was executing all those things correctly. So that's got us home. I never left Maryland a farewell letter. In Apollo 8, I never did either. Now, my two companions, Warman and Anders, wrote farewell letters. Instead, I had Neiman Marcus deliver a Christmas package on Christmas Eve as my farewell letter. And on 13, of course, I never really thought about that. By this time, I thought things were really routine. I mean, there's the chances of a big accident are less and less. We've had a couple of successful flights. Now, at the press conference, after 13, behind me was a lot of NASA's hierarchy. And a newspaper guy got up at this big thing and said, "Jim, are you going to ask to have another flight?" And in that brief moment, that thousandth of a second, I said, "Oh my God, what a chance to get these guys and nail it on." And so I was about ready to say, well, naturally, because, they won't guarantee. And then I looked out in the back of the audience, and there was a hand that went up. And it said, and it was my wife. And so I said, well, I think we ought to let some other people try it. I thought that we should go back to the moon and learn about going to the moon with the proper architecture and make it a routine thing so we can use that to go to Mars. And eventually, because someone's going to go to Mars, only because Mars is there. Well, when I first came down, of course, I thought 13 was a failure. And also, NASA thought it was a failure. They didn't really understand the significance of what happened. As a matter of fact, they tried to emphasize Apollo 12 and Apollo 11. Apollo 13's command module, after it was inspected, ended up in a warehouse. My thoughts are that the accident of Apollo 13 was the best thing that could happen to NASA. People were getting very complacent. And so when 13 occurred, at the time that it occurred, because it could have been a complete disaster, which would have probably ruined the whole space program, it was the best thing that could have happened. Because it brought out the ingenuity, the leadership, and the teamwork that the NASA Control Center had, along with the crew that could actually comply with and execute the things that we got back. And spacecraft of almost certain catastrophe to a successful recovery. So I'm very proud of 13. Even though I didn't land on the moon, that was a disappointment for me. But then, a lot of people landed on the moon, so so why should I? And if 13 was a very successful flight, I wouldn't be sitting here today to talk about it.